Hello students, I am Dr. Neera Sharma. Today I bring you a learning episode in BSc Forensic Science on behalf of the content writers Dr. Vimal Rar and myself on an important unit which is Explosives Part 3. In this lecture, we will discuss about overview of blasting agents and you will be acquainted with the knowledge of synthesis and characteristics of TNT, PETN and RDX. We will wind up this episode with post-blast residue collection and analysis. Let us start our episode with a look at what we are going to learn today. In Module 1, we will see an overview of blasting agents. In Module 2, synthesis and characteristics of TNT. In Module 3, synthesis and characteristics of PETN. In Module 4, synthesis and characteristics of RDX. Module 5 contains detection of hidden explosives. In Module 6, we will discuss bomb scenes management, and in 7, post-blast residue collection and analysis, and finally, we will conclude. A blasting agent is an insensitive chemical composition or combination comprises mainly of ammonium nitrate that explodes when instigated by high explosive primers or boosters. As they do not contain nitroglycerin, blasting agents are comparatively impervious to shock wave, resistance and impact and are therefore harmless to hold and transport. It is a substance or combination that contains fuels and oxidizers which is used for attacking and may not be categorized as an explosive. One category of blasting agents is called nitrocarbonitrates, NCN. It is formed chiefly of ammonium nitrate and oil with special ingredients added to decrease static electricity and avert toughening of agents during storage. All blasting agents comprise the oxidizer, fuel and sensitizer. The oxidizer is a chemical that delivers oxygen for the reaction. Specific oxidizers are ammonium nitrate and calcium nitrate. Fuel could be chemical which counters with oxygen to yield heat. Generally, fuels comprise fuel oil and aluminium. Sensitizer delivers the heat source to drive the chemical reaction of oxidizer and fuel. Sensitizers are usually minor air bubbles or pouches contained in an explosive. Due to its slow action and consequent heaving or pushing effect, black powder was used for years as the only commercial blasting agent. Ammonium nitrate is extensively applied as a blasting agent and by the military as a crating charge. It is also an ingredient in the production of certain dynamites and is widely employed as a fertilizer. A common cluster of blasting agents is called blasting slurries. These consist of NCN mixtures with or without the addition of TNT in a gel-like consistency. Some of the blasting slurries have powdered metals such as aluminium added to increase their performance. The blasting slurries, due to their consistency, can be poured into irregular or wet boreholes to fill all available space with explosives. In 1902, the Germans and British had conducted experiment with trinitrotoluene, initially set by Wilbrand in 1863. The primary comprehensive examination of the preparation of 2,4,6 trinitrotoluene was by Bilstein and Kuhlberg in 1870 when they revealed the isomer pure 2,4,6 trinitrotoluene was formed in 1880 by Hepp and its structure recognized in 1883 by Claus and Becker. The production of TNT started in Germany in 1891 and in 1899 aluminium was combined with TNT to generate an explosive mixture. In 1902, TNT was accepted for application by German army substituting picric acid, and in 1912 the US Army also began to use TNT by 1914. TNT turned out to be the most common explosive for all armies in the course of World War I. The starting material is pure toluene, specially free from unsaturated aliphatic hydrocarbons. This is nitrated in several stages to avoid oxidation side reaction which occur when toluene itself is mixed with strong nitrating acids. TNT is comparatively harmless to carry and of low toxicity. It is therefore preferred to picric acid and ammonium picrate, which give sensitive compounds with a diversity of metals, and to trinitrobenzene or hexatrinitrodiphenylamine, which are highly toxic. Next to trinitroglycerine, TNT is the most significant sensitizing constituent of commercial explosives. For such purposes, it does not require to have the high purity demanded for the military product, but otherwise the material is similar. In commercial explosives, TNT has the advantage of greater safety in handling than nitroglycerine and also less physiological effect. On the other side, it gives explosives which tend to be unreliable under certain conditions. Its use is therefore tending to diminish in Britain, though in many countries it is being applied in slurry explosives for large boreholes. TNT is probably currently the most extensively applied military explosive. Alone or in mixture with further explosives, it is frequently applied as a main charge in artillery, projectiles, mortar rounds and aerial bombs. It is considered as moderately insensitive military explosives. TNT cannot be detonated by heat, shock or friction and is in fact safe even when impacted by a bullet. It will usually burn reasonably, then explode if consumed by fire. PETN, discovered in 1895, is a solid with melting point 141 degrees centigrade and is very powerful explosive. It is very stable both chemically and thermally. Pure PETN is too delicate to resistance and impact for direct application for military purposes. It can usually be mixed with plasticized nitrocellulose or synthetic rubbers to obtain plastics or moldable explosives. The commonest application, however, is in conjunction with TNT in the form of pentolites. Pentolites are usually obtained by incorporating PETN into molten TNT. A minor quantity of the PETN goes into solution, but the bulk remains suspended in the liquid and the whole mixture can suitably be used in preparing cast charges. Pentolites containing 20 to 50% PETN are commonly used. Pentaerythritol is made commercially by the reaction of formaldehyde and acetaldehyde in the presence of alkali. It can be nitrated by adding it to strong nitric acid at temperatures below 30 degrees centigrade. An excess of nitric acid is used so that the refuse acid from the reaction contains at least 75% nitric acid, as refuse acids of lower strength can be unstable. The wash product is reprecipitated from acetone to provide a suitable crystal size and adequate stability on storage. PETN is always transported wet with water and dried only when required. In the course of World War II, RDX was utilized more than PETN because PETN was more delicate to impact and its chemical stability was poor. RDX, Research Department explosive, is also called as cyclotrimethylene trinitramine, that is CTMTN. Cyclonite and hexogen. It is made by the nitration of hexamine, itself prepared from formaldehyde and ammonia. Hexamine was originally nitrated with a large excess of concentrated nitric acid at temperatures below 30 degrees centigrade, and the product recovered by adding the reaction liquor to chilled water. Later, the yield was improved by adding ammonium nitrate to the reaction, as this reacts with the liberated formaldehyde. It converts the hexamine first to its dinitrate, which is then reacted with ammonium nitrate, nitric acid and acetic anhydride, the last reagent being reformed from the product by use of ketene. The RDX can be isolated by evaporation of the liquor and then purified by washing. RDX is a snowy solid melting at 204 degrees centigrade. It was originally discovered by Henning in 1899. It achieved military significance in the course of Second World War owing to its lower sensitiveness than PETN. It is stable both chemically and thermally. RDX may be applied alone in pressed charges, although for this application tetryl is more general choice. For shell and bomb filling, it is too sensitive alone to initiation by impact and friction, and is either desensitized with wax or else used like PETN in admixture with TNT. RDX may also be compounded with mineral jelly and similar resources to contribute a useful plastic explosive. Nitration of hexamine dinitrate in the concentration of acetic anhydride can also give another explosive of high power and high stability called HMX, tetramethylene tetranitramine. There are following types of hidden explosive. Landmines. Landmines are other explosive hazards that comprise abandoned weaponaries and military apparatus, unexploded ordnance and other explosive miscellaneous of war, as well as improvised explosive devices cause a threat all over the world. Mines are applied as self-protective weaponaries. They offer defense for significant military locations or obstruct the movement of troops by producing fatalities to an enemy and destroying equipments. They are also applied offensively, specifically in the course of wars, where they are used to destroy or damage infrastructure and cause terror. Landmines are nearly at all times concealed and disguised to match their backgrounds, making them rarely caught and problematic to trace. They are generally concealed or hidden in grass or buildings, fixed on stairs or to the trees. The conventional method of detecting mines involves the application of a metal detector to find mines. However, with the extensive application of plastic-cased minimum metal content mines, the application of metal detectors is not as much operative in certain regions. This has led to drive to develop and introduce new means of finding mines. There have been many technologies tried, including ground penetrating radar, magnetic resonance imaging and infrared detection, and several are discovered to the world each year. All dogs can smell explosive, and it is possible to train dogs to react in a particular way when they smell the explosive contained in the mines. However, dogs have a limited attention span. The training is complicated and there is a diversity of environmental factors. That means dogs are not always 100% effective at finding individual mines. Even when they react, there is a region of some square meters that should be investigated by a deminer who must take care of the hidden explosives or items of unexploded ordnance that the dog has detected. Properly trained dogs can make a valuable contribution to determine the edges of contaminated areas. Improvised explosive devices and booby traps. An IED is a physically positioned explosive device, normally homemade and adapted in some way to kill, injure, damage property or create terror. Often unexploded ordnance or abandoned munition are modified to construct IEDs that can be detonated accidentally by the victim by isolated way, radio controlled, command wire, etc. or as a suicide attack. A booby trap is an explosive or non-explosive device purposely located to cause fatalities like opening a door or turning on a television. Booby traps, most often victim activated, are generally common objects present at various locations. IEDs and booby traps are generally established by militant opposite forces that has comparatively restricted contact to weaponaries or who require to have deniability of their attacks. Sometimes they are placed with the purpose of producing harm or wound to combatants and non-combatants alike, being hidden in vehicles, on roadsides or in private homes and so on. Bombing and the danger of being bombed are harsh realities in today's world. The public is becoming more conscious of those instances of vivaciousness that are committed by malicious, evil sections of our society, both foreign and domestic, by the unlawful application of explosives. If there is any point that will not be exaggerated, it is the value of being prepared. The investigation carried at the scene of an explosion or blasting plays an important part in discovering the fact about the occurrence. The evidence found can be important in recognizing, charging and eventually sentencing alleged offenders. For this purpose, it is unconditionally crucial that the evidence be taken by scientific method, which will give effective laboratory analysis. One method of confirming that we as investigators get evidence of the good quality and application is to track sound procedures in our investigations. Recent cases in criminal justice system have carried to light the requirement for heightened analytical practices at all crime scenes. Principle: one of the most significant aspects of securing the crime scene is to preserve the scene with minimal contamination and disturbance of physical evidence. The primary reaction to an incident should be speedy and systematic. The initial responding officer, upon entrance, shall evaluate the scene and consider the instance as a crime scene. They shall punctually yet carefully approach and arrive the crime scene, remaining observant of any persons, vehicles, proceedings, probable evidence and environmental conditions. Procedure: the initial responding officer will note or log mail details, example, address, place, time, date, form of call, parties involved. Be alert of any individual or automobiles going or coming in the crime scene. Approach the scene carefully, examine the complete zone to thoroughly assess the scene and note all probable secondary crime scenes. Be observant to note the presence of any individual or automobile in the locality that may be associated to the crime. Make initial observations, look, listen, smell to evaluate the scene and safeguard, officers should maintain security before the proceeding the crime scene. Consider the site as a crime scene until assessed until complete examination is not carried out. Safely direct additional responding units into area. The investigator should confirm the integrity of the scene by stating security levels and staging regions, impurity regulator measures and evidence collection and control procedures. It is significant to an effective investigation to select a team of trained personnel to perform scene processing based on the category of incident and complexity of the scene. While all crime scenes investigation have their specific complications, some circumstances may comprise a typical crime scene location or requirements for which law enforcement personnel and other responders must be aware. The handling of physical evidence is one of the most significant factors of the examination. The investigator shall safeguard the effective collection, protection, packaging and transport of evidence. The team members must preserve scene of crime safely till the processing on it is carried out. Then scene is unrestricted. Document the collection of evidence by recording its site at the scene, date of collection and who collected it. Note the details of each item which is identified as evidence. Establish chain of custody. Obtain standard reference samples from the scenes. Obtain control samples. Take elimination samples from crime scene. Recognize and protect evidence in containers at the crime scene. Various types of evidence involve various containers, for example, porous, non-porous, crush-proof. Package items to avoid adulteration and cross-contamination. Avoid excessive handling of evidence once it is collected. Preserve evidence at the scene in a way designed to reduce degradation or loss. Transport and submit evidence items for secure storage. The accurate and timely collection of evidence can lead to the reconstruction of a scene to determine if a crime has been committed, to the identification of suspects and to the successful completion of the investigation. First responders, investigators and specialized personnel who are well experienced, equipped and prepared shall collect all the potential evidence. Appropriate personnel with the required knowledge and training should collect evidence. Paper bundles or other sterilized swab storage container, distilled water or one-time use sterile water, scalpel, utility knife or scissors, clean paper, waterproof pen, evidence tape, protective gloves, face protection, commercial products are also accessible for crime scene collection. Bombs and explosives identification and collection are best performed by experts. For scene personal evidence may be evaluated through smell, sight and sound. These factors should be recorded in notes. Final review of the crime scene confirms that evidence has been collected and the scene has been managed preceding to release. In addition, an orderly review of the scene confirms that evidence, apparatus or tools found during the investigation are not unintentionally left behind and any hazardous resources or conditions have been informed and addressed. The investigators in charge must certify that every zone recognized as a part of the scene of crime is visually inspected. All evidence collected at the scene carefully. All equipment and materials carried for examination are removed. Any unsafe resources or conditions are reported and addressed. The crime scene is unrestricted in accordance with jurisdictional requirement. Always take photographs depicting the situation of the scene at the time. Identification of explosive and its residue from post-blast sample is challenging. In most blast cases, improvised explosive devices are used. Various analytical techniques are used for the analysis of explosive in pre and post blast samples. Conducting a scene walkthrough ensures that all data has been collected, that constituents are not unintentionally left behind, and that any hazardous substance or circumstances have been described and addressed. Explosive evidence is examined in the forensic chemistry or explosive division, generally in one of the two forms, pre-blast or post-blast. Pre-blast analysis involves the identification of an unexploded material that could range from anything such as gunpowder to C4. Analysis of these materials should be carried in bulk form. However, in most cases, the investigation generally deals with the examination of post-blast materials or debris, which requires the examination to be done on trace quantities of explosives and residual byproducts. This type of analysis employs the application of various techniques and instrumentation such as visual examination, macro or microscopic, order assessments, ignition characteristics, spot experiments, thin layer chromatography, infrared spectroscopy, polarizing light microscopy, scanning electron microscopy or X-ray analysis, other chromatographic methods and X-ray diffraction. Historically, the term explosion has been difficult to define precisely. The evidence that indicates an explosion occurred includes damage or change brought about by the restriction of the expanding blast pressure front as an integral element, producing physical effects on containers or nearby surfaces. A common concept of explosive is that the ignition of the explosive charge causes a high velocity shock wave and a tremendous release of gas. Forensic investigation of explosions comprises of identifying the point of origin, the explosive material involved and the charge mass. The investigation of incidents relating explosives requires very specialized training. Explosives are strictly regulated by local and central laws. So, most explosive incidents will be investigated by law enforcement or regulatory agencies. The aims of the explosion scene analysis are not different from those for a regular criminal investigation. A methodical method to the scene examination is equally or even more important in an explosion investigation than in a fire investigation. Explosion scenes are generally larger and more disturbed than fire scenes. Without a pre-planned systematic approach, explosion investigation becomes even more difficult or impossible to conduct effectively. Dear students, I hope you have enjoyed the study content of this episode. There are certain explosives which draw attention in daily routine, like TNT, ANFO, PETN are some of those examples, being frequently used by terrorists as well as the armed forces. These explosives are always encountered by a forensic scientist. The approach to be followed for the post-blast investigation for these explosives requires special attention. I believe this topic would create an interest within you to learn more about these classes of explosives. Now this is the time for your self-study. If you want to learn more for enhancing your knowledge, you may log on to our website www.cec.nic.in. for assignments, MCQs, quizzes, LORs and other materials. Till then, keep studying. Goodbye.